Hi everyone. We're going to be on page 25 in your notes today. It says Function Families Review on top. So as we're wrapping up Unit 3, this activity kind of puts together all of the things that we've learned. We talked yesterday about those function families that we need to be familiar with. The linear family, so anything that graphs a line, it has just x in its equation, no exponents, no radicals, just x. We've talked about absolute value functions, so they have x in absolute value in their equation and they graph that V-shaped graph. And then we've learned about quadratic functions, which have x squared in their equation and they make that U-shaped graph. And so this activity today kind of brings everything together. We're going to look at some functions. We're going to identify which function family it comes from, so what type of shape it's going to graph. We're going to identify the parent function, and then we're going to fully analyze each of the functions that we graph. Okay, we're going to do about half of them together. I'm going to have you finish up the other half on your own and check your work with my answer key. And with that, we'll go ahead and get started. Looking at number 1 here, it says f of x equals negative 3x plus 5. And I know that when an equation has x in it, and it doesn't have an exponent, and it's not in a radical, and it's not in a denominator, I know that it's going to graph a line. And so right away, I'm going to say, well, this equation belongs in the linear function family. It's going to graph a line. Now, when I'm graphing a line, there's a couple ways that I can do this. I could make a table of points. Please know that making a table of points works for absolutely every function that exists. Always. You can always make a table of points. I can put it in my calculator and I can look at the picture. How I prefer to graph the line, I'm thinking of this as y equals mx plus b. I know that my y-intercept is positive 5, and I know that my slope is negative 3, or negative 3 over 1. Okay, so to graph this, I'm going to put my starting point at 5, and my slope is 3, so I'm going to move up 3 backwards 1, or down 3 forwards 1. And I'm going to do enough dots to cross the whole plane, and then I'm going to connect them with my ruler to graph a nice straight line. Okay, so again here I have verified that this is linear because it's just a line on my graph. And if you graph it and you're like, I'm pretty sure that's what it looks like, remember we can type anything into the y equals menu of our calculator, negative 3x plus 5 and graph. And that's about what my graph looks like. So I'm feeling pretty good about what I've got on my page. All right, let's go ahead and analyze this. I know the parent function for all linear functions is f of x equals x. Remember, it's y equals x with whatever the math action is. This doesn't have a math action because it's linear. And it's got no transformations, no vertical shift, no compression or change in stretch or change in slope. It's just the x. So there's my parent function, f of x equals x. My domain and range on this are all real numbers because it goes all the way across and off the graph. It goes left and right forever. It goes up and down forever. All real numbers. Or you could say negative infinity to infinity if you prefer. All right, end behavior. We talked about this yesterday. We're going to look at the right end as x approaches infinity, and then we're going to look at the left end as x approaches negative infinity. So the right end, as x approaches positive infinity, my graph is going down. Down is negative infinity. So as x approaches positive infinity, y approaches negative infinity. Y is going down. Now I'm going to look at the left side. As x approaches negative infinity, that just means left. The left end of my graph is going up. Up is positive infinity. Now, this particular graph doesn't change directions anywhere. It's only either increasing or decreasing. And so I'm going to ignore the ends of it. I don't want those arrows to throw me off. Notice that from left to right, my graph is going downhill. It's decreasing. It's got a negative slope. Okay, so I say there is no increasing interval, and my decreasing interval goes from negative infinity to infinity. The whole graph is going to be decreasing forever. All right, linear function. Looking at function number 2, I notice that my equation has x inside absolute value bars. Okay, that absolute value bar, that's my action. So that tells me this function family is the absolute value function family, which means this is going to make a V-shaped graph. Okay, so let's graph it and then we'll analyze it. Now, we know 2 ways to graph an absolute value function. We can find the vertex and make a table of points, or we can look at our transformation. So first I'm going to find the vertex. I'm going to take the inside of my absolute value bars and set it equal to 0, and then I'm going to solve for x. And then I'm going to put that x value into the equation to solve for y. 1 minus 1 is 0. 0 minus 4 is negative 4. So I know I have a vertex at 1, negative 4. Now, if I look at my transformations, I can see the same thing. Here I'm shifting to the right 1, down 4. From the origin, I shift to the right 1 and down 4, and that's where I plot my vertex. That's the same vertex that we solved for. 2 ways to find the same thing. Now, absolute value functions have straight arms. Okay, so we only need to find 1 more point on each side of this to know where it's going. Or we can understand what our slope is, and we could use that to find points also. But I'm going to put 0 in for x. 0 minus 1 is negative 1. The absolute value of negative 1 is positive 1. 1 minus 4 is negative 3. Okay, you can also do this in your calculator using the math menu to get to absolute value. I'm going to put 2 in this time. 2 minus 1 minus 4, and I get negative 3. And so I can see that I've got this reflection happening here, and I can plot these 2 points, and I remember that whatever my stretch here is, if there's no stretch, my slope is 1, and if there was a stretch here, it affects my slope. So I know that this graph is just going up 1 over 1 on each side. So I'm going to graph these arms. Okay, there's my graph. And this is another one that I can check in my calculator. I want the absolute value of x minus 1 minus 4. And let's just make sure that our graphs look similar, and they do. All right. The parent function for all absolute value functions is f of x equals the absolute value of x. Okay, it's x with the action and nothing else. So I take out any translations, no stretch, no compression. It's just x with whatever makes it be an absolute value function. My domain on absolute value is all real numbers, but my range is always limited. I have a graph that's going up. Its lowest y value is negative 4. And so I can say y such that y is greater than or equal to negative 4. Or in interval notation, I would say from negative 4 to infinity. All right, looking at my right end, my arrow is going up. So as x approaches positive infinity, y approaches positive infinity. Looking at my left end is also going up. So as x approaches negative infinity, y approaches also positive infinity. And then this has both an increasing and a decreasing interval. Okay, my decreasing interval, if I ignore the arrow here, don't let the arrow confuse you, this section of my line has a negative slope. Its y values are getting smaller as I go across, so that's my decrease. And my decrease changes right here at the vertex. So using interval notation with x values, my decreasing interval is from negative infinity to positive 1. Right here where x is positive 1, it changes direction and it now has a positive slope. And that positive slope is the increasing interval, and it starts at 1 for my x value and it goes to infinity. Okay, downhill decreasing, uphill increasing, using my x values, my domain, to describe each section. All right, equation number 3, function number 3, f of x equals negative x squared plus 8x minus 11. I know by the x squared that this is a quadratic function. That's my function family, so it's going to make a U-shaped graph. I can tell a few things by looking at this. My a is negative, so it's going to open down. And it's got some other numbers on it, so it's going to be scooched around the graph. But it doesn't have a vertical stretch or compression, so it's going to be a standard width. Now, to graph a quadratic, remember that we start with our a, b, and c. And first we find our axis of symmetry. X equals negative b divided by 2a. This is going to give me positive 4. And then I take that x value and I put it back into the equation in place of x to get the y value that goes with it. So we're going to negative 4 squared plus 8 times 4 minus 11, and I get 5. So my vertex, and I'm going to make a table here. I'm going to put my vertex in the middle. My vertex is going to be at 4, 5, and I'm going to plot that point, 4, 5. Now, quadratic equations don't have a slope on the sides because they're curved. So you have to find points on each side of the vertex to know what your graph is doing. You have to have a minimum of 5 points to graph a good quadratic. 6 if they'll, or 7 if they'll fit on your page. So we're going to do 3 and 2 and 1. And so just using this same equation here, we're going to put in 3 and 2 and 1. Okay, now I want to make sure the points on the other side reflect those, so I'm going to do 5, 6, and 7, same equation. 5, gives me a 4. Good. And 6 gives me a 1. And 7 gives me a -4. Okay, I've got my table of points. And I'm just going to plot each one. 1, -4, 2, 1, 3, 4, and I see them reflecting, and I connect with a very obvious curve so that Mrs. Camino knows that this is a quadratic that I'm graphing and not an absolute value. All right, so we've got our quadratic function on our graph. Now we're going to analyze it. The parent function for all quadratics, remember, it's x with the action and nothing else. So I take out any transformations, I take out any other numbers, no negatives. The parent function is the most base equation that we can come down to. My domain here is all real numbers. My range, everything below the highest point. The highest y value here is 5. So y such that y is less than or equal to 5. Or we could say from -infinity to +5. My end behavior, both of my ends are going down. So as x approaches infinity to the right, f of x approaches -infinity going down. And as x approaches -infinity on the left, my y values are going down to -infinity. All right, increasing and decreasing intervals. Remember, ignore the arrow. Look at the section to the left of the vertex and decide, are my y values increasing or decreasing? Do I look like I have a positive slope or a negative slope? Is my line going uphill or downhill? This is uphill, positive slope, y values getting better, bigger. This is a section of increase, and it's going to increase all the way to the vertex. So from -infinity to +4, I have a domain where my graph is increasing value. So from -infinity to 4 is increasing, and then it turns direction and it starts going downhill. So from 4 out to the end, it's going decreasing. All right, I want to do one more together because there's one on the next page that looks different. So turn to page 26, please. And here we have another quadratic function, but it's written differently. Okay, it's not written in standard form, it's written in vertex form. But I have x, and I have the exponent of 2, that's my action. That's how I know this is a quadratic function. Now, to find the vertex, when we're written like this, it's a little different. I have to look at my transformations. This transformation is left 2. So from the origin, I'm going to go left 2 and then down 7. And so my vertex is at -2, -7. And we're going to use that to make our table of points. I'm going to find a few points on each side. Now, yep, I have a 2 here. This is not telling me a slope of any sort. It's telling me my graph is going to be narrower. You still need to find the points because I don't have a regular slope I can follow. I'm going to have a curve here and I need to see where it goes. So we're going to do -1, 0, and +1, and -3, -4, and -5. And we're just going to find each of those points. So I do 2 parenthesis. I'm putting in a -5. plus 2, close that parenthesis, and square it, minus 7. This one gave me 11. That's not going to fit on my graph, but that's okay. I'm going to do it again with negative 4. And again with negative 3. And moving to the other side, we're in negative 1. And good, I'm seeing that reflection happen. Now I'm going to change this one to 0. And I get 1. And when I put 1 in here, I think I'm going to get 11. Whoops. And I do. Okay, so I've got all my points. Let's draw our graph. Negative 5, 11 is not going to fit. Negative 4, 1. Negative 3, negative 5. And it's going to reflect. And then, so again, 1 and 11, that's just going way off the graph. So I'm going to draw my U-shaped curve here. Okay. And notice this is just skinnier than the other parabolas that we've seen. And again, if you want to check to make sure your graph is right, do 2 x plus 2 parentheses squared minus 7. Plug it in, draw the graph. Make sure it looks like what you think it should look like, and it does. All right, parent function of a quadratic. F of x equals x squared. Domain for a quadratic, always all real numbers. But my range, this one's going up, so y is greater than. My lowest point is negative 7. Or I can say from negative 7 to infinity. My end behavior is up, up. The right end is going up, the left end is going up. I've got a decreasing interval on the left of my vertex, and I've got an increasing interval on the right of my vertex. So decreasing from negative infinity to negative 2, increasing from negative 2 to infinity. All right, and that's all of the examples that we're going to do together today. But here's my expectation. You should have about 25 minutes left in class. That is plenty of time to do the next 4 examples. So you're going to graph this absolute value and analyze it. You're going to graph this line, this quadratic, and this absolute value, and you're going to analyze each one. On the rolling podium at the front of the room, you'll see my purple binder that's got my answer key in it. So check your work as you go. Make sure you have this down. When you finish, you can work on that delta math, increasing, decreasing, and behavior practice. Or you can work on your test study guide. And remember, the answer key for that one is posted online. So, enjoy the rest of your day. Keep working hard until the end of math class, and I will see you Monday. Have a great weekend.